Okay, good morning, everybody. So just a quick announcement. If you haven't seen the announcement on OnQ already, there were 2 extra tests posted with their solutions on OnQ. Sorry? Sorry, what was that? Why did I what? Yes, I made an announcement on OnQ last night telling you that 2 new tests that were also available to look if you want to look at some of the old tests. They're under the assignment solutions. The assignment solutions will be updated today too, so I'll post the first 2 assignment solutions when I get home later this afternoon. All right, so I guess we'll continue with the lecture from last class. So we were talking about implementing methods and constructors in a class. We finished the counter and the point. Well, we've implemented part of the counter class and part of the point2 class. I guess we should go back and look at the stopwatch class. So for your stopwatch, you want some methods that start the watch. So when you press the start button, the watch starts keeping track of how much time has elapsed. You want a method that stops the watch. So when you press stop, it stops a running watch and then computes the amount of time that has elapsed since starting the watch. And then finally, we want a method that gives you the amount of time that has elapsed since we last pressed start. So if the watch is running, that's the amount of time we want to return. If the watch is not running, then you want to return the amount of time that elapsed between the user pressing start and stop. The code's on the slides, but I'm just going to go to Eclipse and look at the code in Eclipse instead. So there's our stopwatch class. We're keeping track of the start time and the stop time. Remember, these are coming from this method called system nanotime. We're keeping track of whether or not the watch is running. This is a little bit new. So here we've got a field that's marked final, and it's marked static. So static in this context means that the field belongs to the class. It does not belong to individual objects. Remember how the other fields work. So these are non-static fields. Right? Remember, every stopwatch object gets its own start time, it gets its own stop time, and it gets its own isRunning field. If a field is marked static, that's no longer the case. So if a field is marked static, there's only one copy of the field, and it belongs to the class that it's declared in. So this field called billion is defined in the stopwatch class. It belongs to the class. The individual stopwatch objects do not have their own copy of the field called billion. The field is also marked as being final. So final in Java means when you final applied to a variable or field means that the field, once it's assigned, can no longer be reassigned a new value. So by marking this field billion as final and giving it the value 1 billion, that effectively creates a constant in this case. Right? If we try to redefine the value of a billion somewhere in the class, that won't work. It's also marked as being private, which means it's not visible outside the class. So inside the class, we can use the word billion, and we get the number 1 billion. Elsewhere, we can't use the word billion because it's not visible outside the class. Static belongs to the class. Final means you can only give it a value once. Private, only visible inside the class itself. Okay, so the start method starts a watch running. If the watch is already running, it does nothing. So our first line of code checks whether or not the watch is running. So if the watch is not running, it starts the watch running. So to start the watch running, all you do is record the start time. Right? So we assign a value to raw start time. The time that we assign is just returned by the method nanotime in the system class. Right? Remember, nanotime gives you the most precise timer available on your computer. We then have to remember to set the field is running to true to indicate that the watch is now running. And that's the start method, right? So start simply starts a stopped watch. Stop simply stops a watch that has already been started. So if the watch is started, so if it's running, go ahead and record the start time. Right? So the start time is, again, we obtain that from nanotime. Of course, don't forget to set is running to false. Now, our stop method also does some, also returns a value. And so if we read the documentation for the method, it says it returns the elapsed time in seconds. So pressing stop should return the amount of time that has elapsed since we first pressed start. Right? So we have a couple of choices here. We can either calculate that value here, or instead, I've decided to call the method named elapsed. And so that's the next method here. So elapsed for a stopped stopwatch returns the value that we wanted to return back in stop, right? The amount of time that has elapsed since pressing the start button. But for a running stopwatch, elapsed returns the amount of time that has elapsed since the watch started running. We haven't pressed stop yet. We just want to know how much time has gone by since we pressed start. So for elapsed, the way this works is we get the current time. Again, we're going to do that by calling nanotime, right? And now we choose one of two different paths, right? So if the watch is not running, right? So if the watch is not running, then we actually want to use the stopping time, not the current time, right? So if the watch is not running, simply set current time to the stop time, and now simply return the difference between the current time and the start time. So the difference between the current time and the start time is just the difference, right? Here we want to return the amount of time in seconds. So you have to remember current time and start time are in nanoseconds. So to return the time in seconds, we have to divide by 1 billion, right there. You also have to remember that current time and start time are of type long. And billion, if you go back and look at its definition, is also of type long. So if you simply compute the current time minus the start time divided by 1 billion, you do everything in long arithmetic or integer arithmetic. Here we don't want to do that. We want to actually do things in real or floating point arithmetic. So we want to get something back like 0.5 seconds or something like that. So to do that, we have to do everything in double. The easiest way to do that in this case is to simply add 0.0 to the current time. When Java sees the 0.0 here, it says, well, that's a double value. We're adding a double value to a long value, so it converts the long value to double, and the rest of the calculation all gets done using double arithmetic. And that gives you the elapsed time. Right? You could have done the exact same calculation in stop. So compute stop minus start, divide by 1 billion, make sure it's all done in double arithmetic. Right? But I have to do that anyway if I want to implement elapsed, so we might as well just call elapsed to do the work for us. And finally, we have a little main method here that tries out the stopwatch. So in there's a method called do something. So this method is here strictly for testing purposes. It's meant to simulate some amount of time has passed by. So here we make a stopwatch, we start the watch, we do something for 2,500 milliseconds, so 2.5 seconds, and then we stop the watch. After we stop the watch, we call elapsed to print out the amount of time that has elapsed. Right? We start the watch again, do something for 2,900 milliseconds, stop the watch, print out the amount of time that has elapsed. When you run that program, you get output that looks like this. Right? After starting and stopping the watch the first time, about 2.5 seconds pass by. After starting and stopping the watch the second time, about 0.9 seconds goes by. And that is the implementation of the stopwatch class. Oh, sorry, wrong deck of slides. And so in the slides, all of the code is shown there. All right, so in our classes, we've now got some non-static methods. We've got a constructor in every class. We now want to go back and add some additional constructors to our classes, mostly to make the classes a little bit easier for people to use. Right. So what a constructor does, a constructor is there to initialize the state of a newly created object. You can have one constructor, you can have no constructors, in which case the Java makes a no argument constructor for you. If you define your own constructors, as soon as you define one constructor, Java stops making the no argument constructor for you. You can put in as many constructors as you want, depending on the exact purposes of your class. So you can add in as many constructors as you want, as long as the constructor signatures are unique. All constructors have the same name, so the unique part means the parameter list is unique. For the point2 class, it would be nice to have a constructor that lets the user set both the x and y coordinate of the point at the point at which it was created. Right? So you just put in another constructor. So here's our constructor. Right? The name is the same as the name of the class. We want to let the user specify the x and the y coordinates, so I probably have two parameters of type double called x and y. Right? And here's an example where to implement the constructor properly, assuming I choose the names x and y here, we actually have to use the word this now in order to assign the fields x and y. Right? So in this constructor, we have a parameter that has the same name as a field, and we have a second parameter that's also the same name as a field. Right? So inside of a method or constructor, the name of the parameters have precedence over the names of the fields. Right? So in other words, inside the constructor, inside a constructor, when you say x, you mean the parameter x, and when you say y, you mean the parameter y. So in this particular constructor, whenever we want the field x, you have to write this dot x in front of the, instead of just x. So I want to set the field for the point so that it's equal to that value of x. So here we write this x equals x. We want to set the field y to whatever value that y is, and so we write this y equals y. Right? Don't write it the other way around. X equals this dot x doesn't do what you want it to do. Right? X equals this dot x sets the value of the parameter to whatever the value of the field is. In this case, it'll set it to 0. So that's not what you want to do. Right? We want to set the value of the fields to x and y. So you have to write it as this x equals x and this y equals y. Picture what happens is as follows. So when you write that line of code there, you get a point p in memory. Right? The new operator runs. You get a new point2 object. Point2 object gets created by copying the class. So there's your point2 object. Right? The point2 constructor gets run. The value of this gets set to the address of the newly created object. And the constructor gets the values -1 and 1.5 as its arguments. So when the constructor runs, right, the value of this is the address of the object that was created. The value of its parameters, x and y, are the values that were passed in by the caller, so -1 and 1.5. Constructor runs, and it sets this dot x to x. So this dot x, so it sets this value here to whatever that value of x is there. And this up here, dot y, that field there, gets set to that value of y there. And so the point2 object gets its fields set to -1 and 1.5. Finally, new returns, and it returns back the address of the object that was just created and initialized. So the caller gets back a variable p that points at the newly created point here, or refers to the newly created point. Right? So in the constructor, we've chosen names for the parameters that match the name of the fields. In the Java language specification, it says that the parameters shadow the fields. So in other words, the parameters have precedence over the field names. If this occurs, you have to use this to refer to the fields. And now, you might say, well, why did you choose x and y? And so the answer is, it's because that happens to be a sensible name for x and y. If you choose something else, so like new x and new y, then you don't have to write this x and this y. Right? You can simply write x equals new x and y equals new y. In Java, though, it's pretty common to see methods or constructors whose parameter names match the name of the fields. So it's not unusual to see. Okay, so once you added that constructor, you now let people make a point by using new and a constructor, passing in the coordinates of the point. That's easier to use than making a new default point and then calling set to set the coordinates. Right? And so on our previous example, we had to make a point with our no argument constructor. Then we call set, or we use x or y, the methods x and y, to set the coordinates. Right? Now you can save one line of code and just write that instead. Right? And so adding in extra constructors is primarily for convenience of the user. It makes your class easier to use. Similarly, we might want to add a copy constructor to the class. So remember, a copy constructor copies the state of an existing object. So if I wanted a copy constructor for point 2, we'd make a point 2 object using some other constructor, and then we can copy that point by calling the copy constructor. Right? And so this is one mechanism in Java that lets you copy other objects. Right? So the copy constructor, if it exists, has one parameter, and it's the same type as the name of the class. So for the point 2, the copy constructor is point 2, point 2. Right? The parameter here always has the same type as the class that it's in. So this copy constructor makes a new point, initializes a new point by copying the values of x and y out of the object pointed at, or referred to by other. Right? So other is a point 2 object, so it has a field called x. Right? I'm allowed to access the fields of the other point inside the class point 2 because inside the class point 2, the fields x and y are visible to me. Right? So I can write other x and other y here. Right? We're inside the same class after all, so I have access to the fields of other directly by name. So here we would simply want to say this x equals other x and this y equals other y. Right? Don't flip it around. Don't write other x equals this x and other y equals this y. Right? That sets the value of the other point, which is not what you're trying to do here. Right? You're trying to set the values of this point. And again, by adding a copy constructor, that lets users of the class use your class a little bit more easily. So here's an example here. We make a point using our second constructor there. Then we use the copy constructor to make a copy of the first point, q. If we made the copy, this really is an independent copy of the point. So you've now got 2 points. They happen to have the same coordinates. But if you change one, so if we change the original point p, and then print it out, you see that p changes to 99 and 44. Right? It used to be -1 and 1.5. If you print out q, q has its original coordinates -1 and 1.5. Right? So p and q really do refer to independent point objects. Question or just stretching? Okay. Right. All right. So notice that in these constructors, they all do exactly the same thing, and that's the case with constructors. Right? The job of every constructor is to set the fields of the object. So it's not surprising that all of your constructors are going to do something similar. Right? So for point 2, all 3 constructors have exactly 2 lines of code. Right? What do? They set this x and this y. So back in 121, you should have been told, whenever you see yourself repeating lines of code, you should consider making some common function that does that performs the duplicated code, and then you just call the function. So in this case, one of our constructors does everything we need, so we can use that one constructor to implement the other 2 constructors. Right? So the technique that you use is called constructor chaining. So inside a constructor, you are allowed to call another constructor. Right? If you do this, it's called constructor chaining. To perform the constructor chaining, we recycle the keyword this, which I'll show you in just a second. When you choose to do a constructor chain, the only place you can do it is on the first line of the constructor body. So you can't do it anywhere else. It has to happen on the first line. So what does it look like? Well, it looks like the following. So the second constructor that we implemented lets the caller specify the x and the y coordinate. Right? The no argument constructor sets the values of the point to 0 and 0. So you can imagine calling the second constructor, passing in 0 and 0. Right? The third constructor, the copy constructor, sets this x and this y to other x and other y. So you can imagine calling the second constructor, passing in other x and other y to the second constructor. Using constructor chaining, you can do exactly that. So on the first line of this constructor, we can use the keyword this and then round brackets, round brackets. And so that syntax there indicates that we want to call another constructor inside the same class, right? And so we look for the constructor that has two double values, which is this one here. Right? That calls the second constructor passing in 0 and 0. Second constructor sets this x to 0 and this y to 0, which is exactly what the old implementation of the first constructor did. Right? For our third constructor, on the very first line, we can write this, round bracket, other x and other y. And so that says that we want to call this second constructor, passing in other x for x and passing in other y for y. Second constructor sets this x to other x and this y to other y, and away you go. Right? And so here, we've managed to save not very much lines of code. So we save one line of code here, we save one line of code here. Right? So not the most useful not the most useful example of constructor chaining. Right? But it illustrates the technique. Right? If you want to call another constructor from a constructor, do it on the first line using the keyword this, passing in whatever arguments you need to call the second constructor. Right? So for this particular class, it's not, we only have 2 fields. But if you have a class that has many fields, or if the initialization of a field is complicated, constructor chaining can save you a lot of duplicated code. Right? It works the exact same way. On the first line of the constructor, use the keyword this to call the constructor that you want. Right? The alternative to doing this is to create a method that has all of the code that you want, and then your constructors can simply call the method that contains the code that you want. So that's another way to solve the same problem. Okay, so let's apply constructor chaining to the counter class. So for the counter class, you can imagine adding extra constructors that let the caller or user counter do something specific. We can let the caller make a counter that starts at some other value, right? Some other positive value. And similarly, you might want to let the caller create a constructor by create a counter by copying an existing counter. So the ideas are all the same, right? Let's jump to this version here. So here's a counter constructor that lets the caller set the counter to that value. Now remember, our counter has a restriction on it, right? The counter class says its value is always non-negative. So we can add this constructor, but we have to make sure we don't let the caller make a counter whose value is negative, because that breaks the promise of the class. Right? The class says that the counter value is always non-negative. So here we have to actually check the value of value. Right? So if the value is negative, we have to do something. Right? We can to indicate that this is an illegal value. Right? The way to do that is to throw an exception. So here we throw a new illegal argument exception with a message saying that the value must be non-negative. Right? You could choose to do something else here. Right? You don't have to throw an exception. So if someone passes in a negative value, you can set the value to 0 if you wanted to. Right? So if value is less than 0, this value equals 0, and then this value equals value. So this value equals 0 in this case. That would be an acceptable alternative. In the description of the method, you would have, in the description of the constructor, you would have to tell people, hey, if you pass in a negative value, we're going to take the value to be 0 instead. Right? And so throwing an exception is a pretty common thing to do inside of a constructor. Right? Many constructors need to validate the values of their input arguments. Right? If someone calls the constructor with an illegal value, throwing an exception is a common way to indicate that the constructor has been called improperly. Okay, so now that we've got our constructor that sets the counter to some specified value, we can go back and change our no argument constructor. So the no argument constructor can use constructor chaining, right, and call the second constructor passing in 0 for the value. Right? Similarly, the copy constructor, right? So this constructor copies another counter, can call the second constructor passing in the value of the other counter, right? This is an example of when you should not use constructor chaining, right? So why should you not use constructor chaining here, right? So the no argument constructor sets the value of the counter to 0. 0 is a legal value for the counter. If we use constructor chaining, we're going to test the value even though we know it's a legal value, right? So there's an unnecessary test here when we use constructor chaining. Similarly, if we're going to copy another counter and we've implemented our class correctly, the value of that other counter is a legal value for a counter. So when we use constructor chaining, we again pay the price of an unnecessary test. The test here is not very expensive, right? It's just an if statement. But this is a simple example of when constructor chaining doesn't actually do what you want it does. You end up paying a price for using constructor chaining, right? We pay the price of an unnecessary validation here, right? I know the value of 0 is valid. I don't have to test it, right? I know the value of the other counter is valid. There's no point in testing it either, right? So here's an example where constructor chaining is probably not useful. Oh, okay. And so that wraps up that deck of slides. Any questions about the material that we covered so far in today's? Yes. So when we call some methods, for example, how do we count them here? Static. Static means the thing belongs to the class, right? Constructors aren't methods, so they don't belong to anybody really. Well, they're defined in the class. But the keyword static here isn't, it's not legal, and it's not, it doesn't make any sense in this case either. Any other questions?
Oh, yeah, so for the system, why you post the ones from last year as well?
I don't know how to answer that question. I don't understand why you're asking the question, and I don't know how to answer it. It's a test to let people see what the tests look like.
Okay, so will it be last year or the year?
So you've asked this question many times already, and it's always the same answer. Right? I can make the test look whatever I want to look like. Yes, another question?
Could you go over the duplicate code again?
So all constructors basically do the same thing, right? They're responsible for setting the fields of the object, right? So if your class has 10 constructors, they're probably going to do all the same thing, right? There's going to be this x equals something, this y equals something, this z equals something, right? Somewhere in there. So that means that all of your constructors are going to contain similar looking code, right? So you're going to have 10 constructors. Many of the constructors are going to have code that looks more or less exactly the same. When you're writing code, you want to avoid duplicating code, right? Every time you duplicate code, you have to test the duplicated code. You have to debug the duplicated code. Right? When you debug the duplicated code, if you find an error, you then have to fix the error in all of the other pieces of code that you duplicated. Right? So if you put all of your code in one place to begin with, you only have to test and debug that one piece of code. Then you know that anything that uses that code is probably okay. Right? So in these examples that I'm showing you, the classes are simple. So using constructor chaining doesn't really save you a lot of work. But as soon as you have many, many fields in your class, and you have multiple constructors, right, then you probably want to consider using constructor chaining, or at least a common method that does the initialization for you, and then use the common method.
How is the constructor different from methods, since it seems like they're all, so we're calling them to do something?
So the purpose of a constructor is very specific, right? The constructor is responsible for setting the fields of the object, right? When you create the object, right? So when the object is initialized, the constructors run, because that's the only way you can make a new object, right? And so they are responsible for setting the fields of the object, right? Methods can do whatever they want, right? So
I can't understand it this way, so we are calling constructor to create something new.
no, so new does the new part. So new makes the object. The constructors initialize the newly constructed object.
So then we did put something out of the constructor, a method, and then
Run that by me again. Sorry, ask that again.
So and then we put something out of the constructor.
Put something out of the constructor into the method. I don't understand that part of the question.
For example, the random class.
Yeah.
Create an object out of
Yeah.
and then we put the call method.
You use the reference or the variable to call methods. Yeah.
Like instance method, right?
Yeah. So make a random object. So you use new to make the object, right? You use the constructor to initialize the object that's created. So now we have a newly initialized random object, right? Now you can use the object R to call some method. In this case, you probably want to save the value. Like that, right? So there's a method, right? To call the method, you need the object, right? To make the object, you need the constructor. You need to call new, which needs the constructor. Okay. Someone else had their hand up.
Oh, that's good. Never mind.
Okay. All right. Okay, so the next deck of slides continues the classes discussion. So classes continue. So it's deck 13. Oh, okay. All right, so far in this course, you haven't had to do any documentation of your methods or classes. So this is where I actually tell you how should you document a Java program. So Java is a little bit unusual in that it has a documenting documenting convention that every Java programmer follows. Right? This isn't true in most of your other programming languages. So Python, there's no standard for the documentation. You can write it in, there's several different standard or widely used forms of documenting Python. Java, there's exactly one. And so documenting code wasn't a new idea when Java was invented, right? So for a long time, programmers have realized you have to document your code. The way you document your code was that you print it out. And so you get these big books or binders or something of printed material that contained the documentation for your code. Java embedded the documentation into the code itself. And then it said, let's make a tool that can extract the documentation from the code and produce an electronic document of the code. Right? So Java has this tool called Javadoc that generates documentation from comments embedded in your code. So the comments that are embedded in your code are called Javadoc. And so in the assignment, occasionally that you've seen so far, you'll sometimes get a class, and inside that class there will be these somewhat large comments for the class and the methods and constructors. Right? Those are all Javadoc comments. The documentation that you've been reading for your assignments, those are all generated using Javadoc. Right? So the way Javadoc works, it's a tool that processes the comments in your code. So it's looking for these things called doc comments. Right? Doc comments, they show up immediately before a class, immediately before a field, immediately before a constructor, or immediately before a method. So when you're reading the code that I give you, if there's a big comment in front of a field or a method or constructor, that's the Javadoc comment for that thing. Right? So remember, in Java, you've got the /* as a comment marker. Javadoc star, right? So it's still a comment, but that second star tells the Javadoc tool that this might be a Javadoc comment. Right? The comment still ends in //. Okay, so Java showed up in the 90s, which was when the internet started to take off. And so Javadoc comments are written in HTML. So HTML is a hypertext markup language. It's what many of your web pages that you look at are written in. So your doc comment starts with a description. So the first sentence of every Javadoc comment is the synopsis or the summary of the thing. Right? So that shows up in the summary section of the documentation. And then the rest of the comment shows up in the detailed comment section of the documentation. After the description of the thing, some things have these block tags. So anything that begins with an @ is called a block tag. So constructors and methods, for example, they have block tags called @param, @return, and @throws. Right? @param describes a parameter. @return describes the return value. @throws describes what exceptions might be thrown from the method or constructor. Right? So when you start to write the Javadoc for your class, you should begin, well, your class itself should have a Javadoc comment that describes the purpose of the class. Okay. So when you describe the purpose of the class, right, you don't say how is the class implemented. Right? So in your comment, you're not saying my class has a field of double, right, whose name is X and stuff like that. You simply describe what is the purpose of this class. You might describe what features does this class have that people might want to use. Right? But what you don't say is how is this class implemented. So for example, the point2 class has a very simple Javadoc comment in front of it. Right? It simply says that a point2 is a Cartesian point in 2 dimensions having real coordinates. Right? And that's all it says. You could expand on this documentation here if you wanted. Right? Notice what's not here. It does not say every point2 object has a field of type, has a field named X and has a field named Y. Right? You don't want to reveal any of the implementation details of your class inside of the comment. Okay, so when you run the Javadoc tool on this class right here, right, that description gets put down at the top of the documentation. Right? So at the top of your documentation, notice you have the name of the class, right? You get the name of the package that the class is defined in. Here you get the inheritance hierarchy structure of the class. So this is telling you a point2 object is also a big O object. We'll talk more about that later. You get the declaration of the class. So we see that point2 is a public class point2. That extends object. Right? And then whatever description you have for the class shows up here. Right? If your class has public fields in it, you should have a Javadoc comment that describes the purpose of the field. The idea here is that you want to describe every public feature of the class. Depending on what you're writing the class for, you might want to describe the protected, package private, and private features as well. Right? But for now, everything that's public should be described with a comment. Right? So when you describe a field, you can write out as many lines as you want, but the first sentence of the Javadoc comment appears in the summary section for the field. Right? So in the math class, there is a public constant called E. Right? And E is the double value that's closer to any other to E, the base of natural logarithms. So this is Euler's number E. Pi is the constant pi. Right? And so if you look inside the math class implementation, there's a Javadoc comment that looks exactly like that. Right? These descriptions show up here inside the Javadoc comment for the math class. Okay, so if you have a public constructor, guess what? It gets a Javadoc comment, right? It describes the purpose of the constructor, right? The of the comment goes in the summary section. The rest of the comment goes into the detail section. So here, our point2 class, our point2 no argument constructor says that it initializes the coordinates of this point to 0, 0. Now, notice the funny @code nonsense here, right? So when you're writing the comments for your, when you're writing your Javadoc comments, often in your comment, there will be something that looks like code, right? So you want something, in this case, right, I want to indicate that the coordinates of the point are 0 and 0. So if you want something to stand out as though it looks like code, you can wrap it up in a pair of braces and then put @code inside the braces, followed by the text that you want to format like it was computer code. So when you generate the comment for this, Javadoc will will show this, everything inside the @code part like it was written in computer code. So it uses a monospaced font for that code. Hang on, let me just jump ahead here. Here it is. Right? So there, notice that the 0 and the 0, it gets printed out in a different font than the rest of the description. So the rest of the description shows up in a nice proportional font. Anything written as code shows up in a monospaced font, right? Like in a typewriter style font. So every character gets the same spacing when it's printed out. So if you want something to look like code, just wrap it up in braces and put @code in front of it. And that will cause Javadoc to format it like it was code. If your constructor has a parameter, you need to, or you should, describe the parameter using an @param tag. So our constructor that sets the value of x and y, it has an @param tag. When you write the param tag, it's @param and then the name of the parameter. Right? There's no symbol after it. So there's no colon or a hyphen or period or semicolon or anything like that. Right? Name of the @param space, name of the parameter, and then description of the parameter. If you want to, the description can be much longer. Right? So here we have the parameter x is the x value of this point, and we have the parameter y is the y value of the point. So every parameter gets its own @param tag. Right. Again, notice up here I've got, when I'm referring to the parameter x, I want it to look like it's the parameter x, so it looks like a piece of code. So here I've wrapped it up in an @code. Similarly with y. The copy constructor has one parameter, so it gets one @param tag, right? The name of the parameter goes there, right? Description of the parameter goes there. So in this case, other is the point that you want to copy. And again, when you generate the Javadoc for this, when you generate the Javadoc for the constructors, you get the descriptions here, right? Anything wrapped in @code shows up in a monospaced font. Oh, notice what's not here. So the description of the parameters is not here. That goes into the detail section. So if you were to click on this, if you were to click on one of these constructors, that would take you to the constructor detail part, right, where you get the full description of the constructor. Right. So for the no argument constructor, it looks exactly the same as the summary. But for the second constructor, right, you now get the parameter section here that tells you what are the parameters for. Right. Javadoc inserts that hyphen for you. I don't know if it's always a hyphen either. Different versions of Javadoc format the documentation slightly differently. And there's the detailed description for the copy constructor in this for point. If you have a method, the exact same things apply. The exact same rules apply. So every method gets its own Javadoc comment. If there's parameters, you document them with @param. If there's a return value, you document it with @return. Right? So set sets the coordinates of the point to new x and new y, and it returns a reference to this point. Right? So new x gets its @param tag, new y gets its own param tag, and the return value gets its own @return tag. Right? When you generate the documentation for this particular method, right, you get the parameter description here, you get the return description here. If you have a constructor or method that throws an exception, you document the exception with an @throws tag, and you tell people when will this exception be thrown. So you say what exception is thrown and when might it be thrown. Right. So the counter constructor throws an exception if the value is less than 0. So to document that exception, we write @throws, right? The type of exception that's thrown, the condition under which the exception is thrown. When you go and look at the documentation for the method, right, there will be a throws section in the detail description of the constructor. It'll tell you the exception that's thrown and the condition under which it's thrown. Right. If you want, you can use Javadoc. You can use a subset of HTML in Javadoc. If you know what HTML is, this is useful. If you don't, it doesn't really matter in this. right? If you want to add extra paragraphs in your descriptions, then the way you insert a paragraph is with a P tag. So angled brackets, P inside the angled brackets. So that's the HTML tag for the start of a new paragraph. Right. So for the add method inside point 2, which we haven't looked at, right? It turns out you can add a vector point. A vector is a mathematical vector, right? So you can take a point, add a vector, that produces a new point at the end of the vector. Right? And so here, the description or the summary says that this method adds a vector to this point, changing the coordinates of the point. Then there's a new paragraph. Right? It says use this method when you want to write something like P equals P plus V, right? Where P is a point and V is a vector. The parameter gets its own tag, right? That's the vector that you're going to add to the point, right? And the return value is a reference to this point, right? So notice that this method here changes the point P, right? It's like you were writing P equals P plus V. When you go and look at the Javadoc for the in the documentation, right? Notice that the new paragraph shows up as a new paragraph in your documentation. All right, so that's the basics of writing Javadoc. It's not hard. The hard part about writing your documentation is figuring out the English that goes in, right? That's actually the hard part. And that's a real skill that if you're a professional programmer, you have to master at some point. That article there goes to all the gory details about how you should write your Javadoc comments. You don't have to be familiar with it for this course, but if you're going to write Java code professionally, at some point you need to look at that document. That's the official document that describes how you should write Javadoc for your programs. All right, so we're out of time for today. We'll continue the discussion in the next lecture.